Engineering Foundation's final project, predicting energy output of a power plant. So the background, we want to build a machine learning model to predict the energy output of a power plant, combined cycle power plant, as we see here, based off of some sensor data of these power plants running. So we have 4 inputs: temperature, ambient pressure, relative humidity, and exhaust vacuum. And these 4, again, sort of sensor data are used to predict the electrical energy output of the power plant. So this is the target variable. Looking at the data, there are over 9,000 rows. The sort of shorthand for determining if there are enough rows to generate a strong model is that we need to have 10 times more data points than the number of features in the model. We have 5 features, that's 50. We have way more than 50 observations, so I think we're good in terms of the size of the data. I used Google Vertex AI platform and the AutoML tool within it to generate my models. Google asks a couple questions when you generate a model with it. So here's some of them. Classification or regression, basically, is this a categorical or continuous variable that we're trying to predict? Do we want to use AutoML or another tool? What's the target column? Again, in our case, that's energy output. What's the division of data between training, validation, and test sets? Which columns do we want to use in the training? And then what's the optimization objective? RMSE, root mean squared error, mean absolute error, or root mean squared logarithmic error. To be completely honest, this is the part of the model creation that I don't understand. I don't know how this selection necessarily changes the structure of it, but looking at the results, it kind of makes sense. So we'll get into it in a bit. And then finally, for the project, we had to choose a performance metric. I chose R² value simply because it's a 0 to 1 scale, which is easy to understand, and it's easy to compare it between the different models. And I guess additionally and importantly, Vertex AI includes that statistic in all of the models. So for the first one, I kept it pretty basic in terms of what the platform defaults to. I used regression because it's a continuous variable. I used all of the columns in the training, so I used all 4 of these to do the prediction of energy output. And then for optimization metric, I used root mean squared error, which is the default, and it seemed like a good place to start. I know the difference between RMSE and mean absolute error is that this one is a little bit more affected by outliers. Not really sure what the data looks like in terms of the distribution, but I figured why not start here. So I generated this model, and the output was an R² value of 0.964. So this is very strong. So I felt like I was very happy to start here. And so for model B, in terms of how we could change that, I thought maybe we could change the optimization objective. Again, I wasn't really sure what the shape of the data was, but I figured maybe if we are less sensitive to outliers, maybe that could generate a stronger model. So I kept everything else the same, but ran it with this optimization objective, and that resulted in an R² value of 0.954. So again, still strong, but lower than the first one. So it is a slightly worse model in terms of predicting that energy output. I wanted to try one more thing. So one statistic that Google generates is this feature importance. So saying which one of the inputs or ranking the inputs based on how much they were used in the prediction of the output value. And I noticed that humidity is at the bottom for both. So I thought maybe I'm going to stick with model A in terms of using RMSE as the optimization objective, but I'm going to remove relative humidity. This simplifies the model and makes it run a little bit easier, and also maybe it will create better results. But I see that it didn't. It generated an R² value of 0.939. So that's the lowest of all 3. So I guess that humidity is still useful in the prediction, even if it's less useful than the others. In short, the model I choose is our model A, which was an R² value of 0.964, which again is a strong value. So the model did a good job. It performs well at predicting energy output. I'm satisfied with that. I feel like I kind of tested a couple different types of models, and I found the very strong result out of as a result of that. And I really liked Google's AutoML tool. It was easy to use, and it